Machines That Fail Us, a podcast by the Media and Culture Research Group at the University of St. Gallen about the human rights implications of AI errors and failures and our future with artificial intelligence. In this final episode of Machines That Fail Us, we turn our focus to the often overlooked environmental dimensions of artificial intelligence and its role in exacerbating the climate crisis, arguably the defining challenge of our time. As AI systems become increasingly embedded in every layer of digital infrastructure, the material and ecological impacts also expand, an aspect that, despite its critical relevance, is only occasionally addressed in public discourse, which remains largely driven by hype, promises, and productivity gains. In this episode of the podcast, we explore the environmental footprint of AI across its entire supply chain, from the extraction of critical minerals for hardware production to the immense energy demands of training large-scale models to the cooling needs of data centers and the long tail of electronic waste. How and where is this impact most visible? In what ways does the environmental cost of AI differ from that of earlier digital technologies? The episode also addresses possible path forward, discussing what mitigation strategies are being developed, both technically and politically, and how realistic are they in practice. For instance, can green AI become more than a rhetorical promise? Bringing together the insights from research from one of the most engaged and important research centers in this area and interdisciplinary perspectives from computer science to social sciences, this episode offers a grounded, critical view on how AI technologies are shaping and being shaped by planetary limits. With AI becoming more and more central to our life and culture, we must continue discussing how its use also intersects with the climate crisis. This podcast always discussed how to build a more human and fair future with machines and artificial intelligence. And we should never forget that this will only be possible by safeguarding the only planet we can inhabit, together with all its ecosystems. There is literally no AI future without this conversation. Thus, for this final episode of Machines That Fail Us, I'm joined by Dr. Noman Bashir, who is a Computing and Climate Impact Fellow at the MIT Climate and Sustainability Consortium and a researcher at the MIT Computer Science and Artificial Intelligence Laboratory. His research and work focuses on rethinking the sustainability of computing and artificial intelligence by moving beyond the traditional emphasis on energy efficiency. To address these emerging challenges, Noman works to develop systems, algorithms, and metrics that treat sustainability as a core design objective, placing it at the center of computer system architecture and operational decision-making. For instance, one of his solutions to improving resource efficiency in data centers is deployed on all the Google data centers, serving applications such as Google Search, Gmail, and YouTube. Before joining the MIT, Noman was a postdoc researcher at UMass Amherst, where he also completed his PhD in computer engineering. So, Noman, welcome to Machines That Fail Us. It's great to have the chance to chat with you today.
Thank you. Thank you, Philip, for inviting.
So my first question is about discussing how the environmental impact of artificial intelligence became a topic of discussion in this area. Because conversations around the materiality of digital technologies, for instance, have been there for a while in media studies and beyond. And I'm curious to know how this became an issue when it comes to artificial intelligence, and how are these debates evolving?
So if I talk about the broader environmental impact of computing itself, there has been academic studies for the last 10, 20 years, but most of the time they faced kind of skepticism if this was a real problem, because if you look at the total environmental footprint of computing before AI, it was less than 1% or so. So people would not pay as much attention to it. However, if you look at post AI, like by post AI, because AI has been there for a while, but I am talking about more generative AI or chat GPT, maybe a like good kind of like milestone. The energy footprint and the carbon footprint of AI has grown rapidly. And in 2022 or 3, I think it was around 4%. And before 2030, it is expected to consume 12% of the electricity in United States. So this problem has become significantly bigger, and the pace at which the footprint or the energy demand is increasing, that has brought a lot of attention to it.
Okay. And overall, do you think that the impact of generative AI and all the other forms of AI we may have the chance to kind of interact with in the future, the impact will be bigger than other like digital technology we are now very familiar with, like the one we are using, for instance, now for recording this, or the emails we have changed and social media? Do you think AI will become bigger in terms of footprints and impact on the climate at large?
Yes, definitely. Because if I look at, so I am a computer systems person.
Yep.
I look at how data centers operate, what kind of workloads run there, and how they are evolving over time. So if I look at that, data center have increasingly more GPUs. A lot of like workloads are AI workloads. So incremental demand in computing is coming mostly from, like, marginal demand is coming mostly from AI workloads. So yes, for the last couple of years, it has like the training aspects of AI models have dominated the discussion. But moving forward, as more and more people have access to these tools, the inference workloads where you are asking it some questions or using it to generate a video or an image, that is going to be more dominant. Because just, even though like individual queries or individual tasks would be much less energy intensive, the sheer scale of deployment would make it like significantly more intensive overall.
So we may also say that the computing power that it's needed to let AI function and work, it's also bigger than, for instance, the one that is required for sending emails. Sorry for
Yeah.
making kind of very basic examples, but I think it's interesting to get to
No,
the
no,
core of
yeah,
the problem.
definitely. I think maybe like a more popular kind of like comparison that people make is between a Google search and a
Yeah.
chat GPT query. So there are different estimates. Every study has their own kind of methodology, but in academic space, it is generally accepted that AI or chat GPT based queries are 7 to 10 times more energy intensive than a typical Google search. So, yes, they are significantly more intensive to just run. And then there is also the overhead of training those model, data collection,
Yeah.
and all of that. So, that is basically text based things. But if you, let's say, ask chat GPT or some kind of like other model to generate an image, that could be up to 1000x that of a simple Google search.
Right. And do you think that the public is aware of this kind of footprint and the kind of impact that these technologies are having on the environment? Do you think there is enough awareness on the users side of things?
I Unfortunately, I don't think that is the case. There is general sense of,
Mm,
okay, there is like a discussion around climate change and how humans are contributing to it, or how AI is going to like ruin everything or something. But most of those concerns, I think, stem from two things. First, AI going out of control and like messing up everything. Or
yeah.
the second one is mostly about like ethical issues of bias and fairness, and when you apply it to, let's say, assess credit card applications and so on. So things like that have much more, like, they have been at the surface, and general public probably knows those implications better than the environmental implications, because you don't really see those things. Because this concept of AI running in some cloud and things like that,
Yeah.
they don't manifest as physically in our lives as maybe a bias would.
So there is also like, I'm very fascinated, for instance, with the metaphors that we use to describe technologies in general. You just mentioned the cloud, for instance,
Yeah.
you know. So the cloud looks like something that is outside of the planet, but it's actually the materials and the kind of the infrastructure that you need in order to have the cloud, whatever that is, are really, really, really on the ground in the planet we also live. So maybe there is also the same issue with making sense of what AI actually is when it comes to the hardware side of the technology.
Yes, I think the data centers that power these AI tools and applications, they are fairly concentrated in certain places around the world. And in
Right.
those places, there is significantly more understanding of the implications they are having in those regions. One of those regions is, let's say, Northern Virginia in United States, or Iceland, where people are now like have protests to not install more data centers. In
Yeah.
Dublin, it's already kind of Ireland 20% of the electricity. In Northern Virginia, there is also opposition. So there are like physical kind of like impacts on the surrounding communities that are significant, but for the broader like world, they are not as real. You may have seen like there are XAI's data center images circulating, like at least my social media circle, like on
Yeah.
LinkedIn and whatnot, where there is a lot of like smoke and smoke like coming out of
Yeah.
the data center, because it is using on-site diesel generators and other kind of like generators, very pollutant generators, to power their data center. So yeah, so local impacts are much more pronounced and they have health impacts and so on, and people know that. But broader public, like because they don't really interact with
Yeah.
data centers and what do they mean for the communities or the broader like health of the environment, yeah, broader public does not have that deeper level of understanding, and they don't really tie generating an image to how much energy or water would you use and how much carbon would you emit when you do those things.
Yeah, and also the water is also very difficult to imagine that you actually need
Yeah.
water to have ChatGPT running. But that's also like a big discussions also outside of the US, also in other areas. So also there is probably also some resistance to this.
Yeah, so water is interesting for two reasons. Like one is, I think, because these chips are super powerful
Mhm.
and they don't really have any mechanical moving parts. So in that case, all of the energy that they use is converted into heat. That is a basic kind of like fact. Like if you
Yeah.
use energy, it is converted to heat. So that heat in a concentrated data center, now you need to dissipate that heat. And the more concentrated source of heat you have, the more energy you need to spend to heat it, and or the more water you use to cool it down. So there is that data center within data center water use, but also there is indirect use, which is like in thermal generation based systems such as coal powered plant or gas power
Mhm.
plants. Over there is a significant water use as well to generate steam, and there is a loss of water over there, and all of these uses require fresh water. You cannot just use seawater like for these applications, because that would corrode all the equipment. So it directly competes with the public use of water. So that is a major impact. And in some cases, like for example, if you build a data center in Arizona, which is already like have less
Yeah.
water, it is going to have long term impacts which may not be visible immediately.
Right. And some of these discussions sometimes are focusing on the kind of personal responsibility of users. Like we are encouraged to use the tools responsibly only if it's really needed, avoid excessive consumption and pollution, and all these things, which are absolutely right. But is this approach kind of sufficient, or is there like a greater responsibility that lie in how the industry operates? So can we as individuals, you know, make a real impact if the industry by itself is not behaving in the most kind of effective way?
Yeah, I don't think that is going to be sufficient. Like
Right.
individuals should be very judicious in their use of technology, and that is there. However, like how immersed we are in technology,
Mhm.
and in a lot of cases you don't really have control over whether you use AI or not.
Yeah.
So, for example, if you search something on Google, it has that AI kind of generated summary. I don't
Yes.
know, like, I have not really put a lot of effort into figuring out how to turn that off, but there is no quick button on the page that I can just like click, and it there won't be like that won't be generated. So things like that are beyond your control, but even when you they are under your control, because the choice is not really binary. It should not be that whether use AI or not use AI. Judicious use of AI requires a lot more information. Okay, this model has less footprint versus that model,
Mm.
or this task is very more energy intensive than the other one. Now that information and the number of models that are coming out and the applications that are coming out, it's very hard for a person who is working on these topics to make these decisions in their
Yeah.
personal life, let alone a common user who has 100 other things to worry about. So I
Yeah.
don't want to say that like individual users cannot do anything, but I think a better kind of like focus would be on policy or regulation based interventions or incentives that kind of like drive a more sustainable development in AI technology.
And this is a good anticipation of my next question, because I would like to ask you, who should bear the responsibility for reducing the environmental footprint of AI? Like, is it all about the developers, the companies, or can policy, for instance, you just mentioned, for instance, make a real change in that? So there must be also push from the policy side of things. And do you think that is happening maybe?
I think there are a lot of questions. The way I see it, maybe I roughly classify it into three levels. So, first one is accounting for footprint, like how much is there and where it is happening. That in itself is a very hard task. For example, if I talk about GPU manufacturing, they are part of like very complex supply chains. It's very hard to estimate and give a number to the footprint. And even within a data center, there are multiple applications running. So, and data centers are in different location. It's a highly distributed set of
Mhm.
infrastructure, so it's very hard to account for all of the things. Once you have done accounting, the second part is attributing who is responsible for it. Now, that is a very tricky question in a sense. Okay, I have most of my AI technology or in general, like computing, available to me for free. Like I Google search is free, Instagram, Facebook, Twitter, like most of everything is free. So I am using them. Maybe I should be responsible for a part of it, like
Yeah.
carbon footprint, or should it be the company that is making money out of my use of that platform and not me, because I am already giving my attention or my time to them
Yeah.
and they are the one making money. I am not the one that is making money out of Facebook use or something like that. There is a social value. Then if you go into the nitty gritty details, there are other things like, okay, if a GPU manufacturer, is it the person who is using it or the developing it and so on. I think it's very hard to kind of answer, because and once you kind of attribute, then the next question would be what is the right set of incentives
Mm.
that should be devised to make more sustainable decision making. If as an end user I don't have any incentive to be mindful about AI use, because I am not, let's say, paying for it
Mm.
in most cases, and I don't really feel the burden of it immediately. So, I mean, I don't have a good answer to it, but to just point out that even if you are well intentioned and really want to do something, it's a very complex space, and
Yeah.
whatever solution that you come up with, it would have some drawbacks over the other. However, having said that, it doesn't mean that it's a hopeless situation. There are definitely, on
Sure.
the individual user side, there is responsibility, or they should be more mindful. A company should try to run their infrastructure in a more sustainable way, so that they, like for example, run when the low carbon energy is available on the grid, run most of their, like shift some of the workloads there and so on, and
Mhm.
then pushing their manufacturers and supply chain to be more greener and so on. So there are, at a very high level, there are kind of like recommendations, but kind of any nitty gritty or fine, it would be very hard to answer and be very
Mm.
context specific for different regions and industry.
That is also difficult, maybe because the supply chain for AI, it's so big. I mean, it
Yeah,
involves hardware down to, any kind of application. So
yeah,
maybe it's difficult also to find a balance to kind of make every piece of the supply chain somehow greener. So
yeah.
it is really like a planetary computational machine, probably.
Yeah, and I think the problem that makes it hard is the pace of development.
Mm.
Because if I look, like, in my mind at least, the technological leaps or the changes that happen over the last couple of centuries, they were fairly slow paced. Like
Right.
cars did not immediately become available to every household in United States or
Yeah.
across the world. Electricity was slowly becoming available to people. However, with everyone having smartphones and any developer having the
Yeah.
capability to develop an app that can be downloaded, it's widely accessible to everyone and very, very quickly. And also, it's changing very fast. If you design a policy intervention 5 years ago for AI, that would be meaningless right now because things
Right.
have changed significantly. Yeah, I think the pace is the main issue. If it was happening at a much slower
Yeah.
kind of pace, it would have been more manageable.
And instead, generative AI arrived in everybody's home like
Yes,
overnight. Everybody was using it, and there was probably also no time to kind of digest how that was
exactly.
going. Yeah. The could have done probably a better job in thinking proactively in that direction. But let's see what the solutions are, because your work is also going in that direction to develop solution to at least kind of make the situation better. So I also would like to send out like a positive message out of this, that something can be done. And I wonder, what are the breakthrough in AI development that you think could most reduce this environmental impact, and what has been kind of done in a very practical way to find at least some solutions to all these issues we have been discussing?
Yeah, even though like I talk about the environmental impacts and what are the wide kind of range of impacts, I don't think the picture is as pessimistic as
Mhm.
it would come out from the discussion so far, because I feel that there are a lot of like good things that are happening. So I would start with the industry itself. So
Sure.
all the companies, Google, Microsoft, Amazon, all, or even OpenAI and all of those, they are taking some meaningful steps to make their operations greener. So for example, Google is kind of leading in terms of renewable energy procurement to run their data centers on green energy. So that is kind of like one of the examples. Then Microsoft has like a lot of people working on how to reuse existing hardware so as that you don't have to manufacture more of it. There is also work being done on cooling, liquid cooling, which is more efficient and does not waste as much water as direct air cooling and so on. So there are meaningful things that industry is doing. On the policy space, I think there are quite a lot of like positives in Europe,
Mhm.
in terms of like regulations of at least understanding the environmental impact, and then maybe having some kind of regulations around making it visible to the users and maybe reducing it. And like in the research space, there are a lot of people working on, given a workload of AI, let's say, which is given a workload, how can you run it in the least carbon intensive or least energy
Yeah.
intensive manner? That is where a lot of my work has been on, because the energy generation mix of electric grids varies worldwide. So electric grids like worldwide have different energy mixes, such as California has more renewable
Hmm.
power and like more solar, so it is greener during the day. On the other hand, Quebec is overall greener because it has nuclear and hydro. So there is an opportunity to shift workloads around to run them when and where low carbon energy is available. So that is one way. Another kind of like a really exciting effort that I like is, rather than everyone training their own
Yeah.
model, there are now more public repositories of open source models that anyone can use with a little bit fine tuning or like just directly. So, such as Hugging Face has their own public repository. Amazon and Microsoft are also building their own. So, basically, down the line, or even now to a large extent, that people would have models that are kind of fine tuned for their task, or general models available to them so that they don't have to train them from scratch.
Yeah.
And I think that is a very positive development that I'm excited about.
So in the podcast, we have always also discussed the future with artificial intelligence and how to make it more human, fairer, and all these things. And I would say that this environmental side, it would be kind of the beginning of any of these conversations. Do you share this view? Like we cannot do AI if we don't have like a planet, for instance.
Yeah, of course. I mean, I am of that belief. I work in this domain.
Yeah.
There is like, I think people, broader audience probably needs to understand the implications of it. Yes, it is six now, like even if it is 10% of electricity, it is rising very, very fast. And it is going to have a lot of implications for local communities, for broader like environmental impact. So it is a serious problem. Some people think that AI is going to solve all the problems
Yeah.
that are out there, and it is going to solve the problem that it will generate. However, there is not a lot of evidence to that.
Mm.
Even if we look at most of the AI applications that are in public domain nowadays, they are around like summarizing text or generating new text or generating images and so on, which are helping in productivity, but they are not groundbreaking for, like, let's say, sustainability. Because if you make a case that it may, let's say, you can use AI to integrate more renewables into the electric grid, there are studies that show AI is also being used to enhance the efficiency of fossil fuels
Mm.
so that they stay on the electric grid much longer. So it's kind of a double-edged sword. So it is not going to solve all the problems. It is not going to solve on its own. There needs to be a intention behind how we use AI and what applications this is being used for. So I think it needs to be more like mindful activity than just hoping that it is going to solve.
And all the episodes of our podcast have been about the errors of artificial intelligence. So I wonder whether in this conversation we are having on the climate impact and environmental kind of costs of the AI, this idea of the error resonates with you, and how.
Yeah, so I think again the error, for me, it comes from like two things. First is about the capabilities that we presume that AI has.
Yeah.
A lot of what we are seeing is around the hype and not the realized benefits.
Yeah.
Like there are going to be a lot, but not as much as the hype. So I think there is an error there. Second error is probably in the estimate around environmental impact, that people think it's minute, it is not going to be a huge problem. The some X industry is producing more emissions than data centers,
Mm.
but that is kind of not the point. Like data centers are bigger than aviation now,
Yeah.
so for sure. But people would say, okay, if water use of a data center is similar to a golf club, and that doesn't do anything for me. Okay, sure, that should also reduce. It doesn't mean that
Yeah.
if golf club is using water, data centers should be able to waste it. Like, yeah, it's just like, I mean, there is a lot of whataboutism that, okay, AI is this, what about that,
Yeah.
or so on. So I think that there is that error over there.
And I think this underestimation is probably the most important error we should not commit. We want to have like a fairer and more human future with artificial intelligence. Noman, thanks a lot for joining the podcast. It has been great to chat with you, and also a great way for ending this season of Machines That Fail Us. Thanks a lot.
Thank you.
The Machines That Fail Us podcast is produced by the Media and Culture Research Group at the Institute of Media and Communications Management at the University of St. Gallen, together with the Communications Department of the university. The post-production is curated by Podcast Schmiede. The next episode of the podcast will be released next month. You can listen to all the episodes of Machines That Fail Us on the University of St. Gallen website, the Human Error Project website, and all major audio and podcasting platforms. This is Philip Di Salvo, and on behalf of the entire Media and Culture Research Group, thank you for listening.